In mathematics, the additive identity of a set which is equipped with the operation of addition is an element which, when added to any element x in the set, yields x. One of the most familiar additive identities is the number 0 from elementary mathematics. But additive identities occur in other mathematical structures where addition is defined, such as in groups and rings. Elementary examples. The additive identity familiar from elementary mathematics is 0, denoted 0. For example, 5 plus 0 equals 5 equals 0 plus 5. In the natural numbers n and all of its supersets, the additive identity is 0. Thus, for any one of these numbers n plus 0 equals n equals 0 plus n. Formal definition. Let n be a set which is closed under the operation of addition, denoted plus. An additive identity for n is any element E such that for any element n in n, E plus n equals n plus E. Example. The formula is n plus 0 equals n equals 0 plus n. Further examples. In a group, the additive identity is the identity element of the group, is often denoted 0, and is unique. A ring or field is a group under the operation of addition, and thus these also have a unique additive identity 0. This is defined to be different from the multiplicative identity 1 if the ring has more than one element. If the additive identity and the multiplicative identity are the same, then the ring is trivial. In the ring mm times n of m by n matrices over a ring R, the additive identity is denoted 0 and as the m by n matrix whose entries consist entirely of the identity element 0 in R. For example, in the 2 by 2 matrices over the integers m2, the additive identity is. In the quaternions, 0 is the additive identity. In the ring of functions from R to R, the function mapping every number to 0 is the additive identity. In the additive group of vectors in Rn, the origin or 0 vector is the additive identity. Proofs. The additive identity is unique in a group. Let B a group and let 0 and 0 in G both denote additive identities, so for any G in G, 0 plus G equals G plus 0 and 0 plus G equals G plus 0. It follows from the above that equals plus 0 equals 0 plus equals the additive identity annihilates ring elements in a system with a multiplication operation that distributes over addition. The additive identity is a multiplicative absorbing element, meaning that for any S in S, S0 equals 0. This can be seen because the additive and multiplicative identities are different in a non-trivial ring. Let R be a ring and suppose that the additive identity 0 and the multiplicative identity 1 are equal, or 0 equals 1. Let R be any element of R. Then R equals R times 1 equals R times 0 equals 0, proving that R is trivial, that is, R equals 0. The contrapositive, that if R is non-trivial then 0 is not equal to 1, is therefore shown.